Right, second part of this lesson, the sine rule. The sine rule is used for finding either an unknown length or an unknown angle, but it's in a non-right angled triangle. So the trigonometry that you would have done up to now was all right angle triangles. Now we're going to be dealing with triangles like this one here, where we don't know if there's a right angle or not, possibly not. And so in the last video, we mentioned about labeling up your triangle with uppercase A for a vertex or an angle, opposite lowercase a for a length, and so on. The suggestion I'm making here is to relabel your triangle to match the rule rather than relabeling the rule to match the triangle. It is your choice, but I think to scribble out the labels on the triangle is possibly a bit easier, and so you're sticking with the same rule. So this formula will most likely be given to you in the formula booklet that you're using for exams. So this is our formula here for the sine rule. Now it's a little bit strange because first of all, we're given two versions of it. Second of all, it's like an equation with three parts, which we're not used to seeing. We're not going to go into the proof of the sine rule here. We're just going to learn how to use it. So why have we got two different versions? Now, they both are the same thing because basically they've just taken the fractions and flipped them upside down. If you were looking for a length, it's easier to use this top version here because the lengths are all the numerators. They're all on top of the fraction. And so generally, it's going to be easier to isolate them. If you're looking for an angle, you should use the second version because here you'll notice that the angles, the uppercase letters, are on top. And again, when our unknown is on the top of the fraction on the numerator, it's easier for us to find it rather than when it's on the bottom, we've kind of got to dig it out of there. So the other thing, why is there three parts? Now, as you know, there are three sides on a triangle and three angles in a triangle. So this applies for any of the three sides and angles. But in our questions, we're only ever going to need two parts of this. So you choose the A's and the B's, or the A's and the C's, or the B's and the C's, whichever you need, depending on the question. There is something you need to be careful of, and we call it the ambiguous case. When we're using the sine rule, it will always calculate the acute angle, the small angle in the triangle. Now, based on the information we're given in a question, it may be possible to draw the triangle in two different ways. One way would give an acute angle and the other way would give an obtuse angle. The sine rule will always find the acute angle. So if the question says find the obtuse angle, you take your answer and you subtract it from 180. Or sometimes the question says find two possible values. And that's a hint to you also. After you've used the sine rule to find the acute angle, you subtract your angle from 180 to find the other obtuse angle. All right, so let's look at this question. Two triangles, both have sides AB, BC, and two triangles, and an angle ACB is 38. What could this be? Show that the angle BAC for one of the triangles is 132 degrees. Okay, so I think I'm going to need a little sketch first. A, B, C, AB is 5.3, BC is 6.4, and ACB is 38 degrees. Show that the angle BAC, that's this angle here, is 132 degrees to three significant figures. I'm just going to put a box around three significant figures so I'll remember to come back to it. But 132 degrees, this doesn't look like 132 degrees. We've got our ambiguous case at play here. There's more than one way to draw this triangle. Now, I could have actually drawn this triangle like this, with AB still being 5.3, CB still being 6.4. I know in my diagram it looks a little bit longer there, but it could potentially still be 6.4. My angle BAC is now this angle here, and you can see the angle BCA is 38 degrees, and the angle BAC is theta. Now that is a more realistic 132 degrees. So it's going to be the second case here. Let me just show you a picture of the two possible diagrams put together and you'll see that ambiguous case a little bit more clearly. Here's my two triangles put side by side with the lengths for ABC, this is the first type of triangle I drew. And then this is the second option I drew. And you can see all of the lengths and the angles are all in where they should be, but your angles here at the bottom, the 48 and the 132, they're lying in a straight line. They're going to add up to 180. Anyway, let's get down to work and find these unknown angles. What was I asked again? Show that the angle BAC, so let's take this diagram here because that's the one that we know is the realistic looking one. And we've got to show that that angle theta is 132 degrees. So let me just label up what I've got here. I have got an angle and a side opposite here. I've got another angle and a side opposite here. And this is the situation where we use the sine rule. So later in the video, we're going to meet the cosine rule, and which is also for non-right angle triangles, but there's different situations where you use each of them. For the sine rule, you're looking for opposite angle side pairs, and you'll have one complete angle side pair, that's the 38 and the 5.3, and then your other angle side pair is the theta and the 6.4, incomplete, and we'll use the sine rule to figure that out. Now, let's label everything up then. I'm looking for angle A and I know length A. I know angle C and I know length C. And so I've got two versions of the sine rule here to choose from, the one with the lengths on top and the one with the angles on top. We're trying to find an angle, so we're going to go with the second version because, like I said earlier, if the thing we're trying to find is on the top of the fraction, it'll make our life a little bit easier. It's just one less step of working out. All right, so let's state the parts of the sine rule that I need and then sub into my formula. So I have got sine of A over A is equal to, what else do I know? I know angle C and side C. So sine C over C. I don't need the B bits at all because I don't know the measures of the B angle or the B side and I'm not asked to find them. So now we sub in everything that we know. Sine A, I don't know what A is. I've called it theta. You can keep calling it A if you want. Over A, and length A is 6.4, is equal to sine C, which is sine 38 over length C, which is 5.3. So now I need to rearrange this formula to find theta. So we've got sine theta and it's divided by 6.4. So the first thing I'm going to do is move that divide by 6.4 over to the other side and multiply it. So we're doing inverse operations if we want to kind of undo or reverse that divide by 6.4 on the left. We do the inverse operation on the other side, multiply by 6.4. So this is where the rearranging formula we had from Algebra 1 becomes really, really important. So now we're trying to find theta, so we need to inverse the sine. The sine needs to go away. How do we get rid of the sine? We inverse sine the other side. Now, don't be splitting this up into small little calculations and doing it bit by bit in your calculator. Do all of your rearranging. If your rearranging skills aren't good enough, you need to go back to Algebra 1 and work on those. So do all of your rearranging and then type the whole thing into your calculator in one go. All right, so that gives me 48.025. And what was I asked again? I was asked to show that it's 132. Oh, that's right. Look at the picture. We had two different cases and we said the sine rule will always find the acute angle. I found that 48. I need to subtract it from 132 to get the obtuse angle. So the angle BAC is actually 180 minus 48.0. That's to three significant figures, which is 132 degrees to three significant figures. That's what we were asked to show. What's the second part of the question then? Find the angle ABC for the other triangle. Now, which is the other triangle? We've just found this 132 degrees. So it looks like we've been working on triangle number 2 here, and they want us to find ABC. This is the angle up here they're trying to get us to find. We'll call that phi. Oh, look, it's just a triangle. I can just do 180 minus 48 plus 38 is equal to 94 degrees. Any rounding I need to think about? It just says find the angle ABC. It doesn't say anything about rounding, so I think I'm good. Okay, there was a lot on that. We got to practice the sine rule and we went straight in with the ambiguous case. So not the easiest of questions, but we did take a lot of skills there. Over to you for the next question. Do make sure that you rewind and make your notes for this ambiguous case sine rule question because there's a lot of good stuff in that one question. And then pause and have a go at the question on the right. I think you'll find it a bit more straightforward. When you're ready, press play and watch me doing it. Okay, 12.6 centimeters. Oh, so Little bit of difficulty there because we had an angle side pair and we didn't know either of the pieces of information. So we had to go back to the drawing board and look at what we found out in the first part of the question and then use the three angles in a triangle adding up to 180 to find that angle at B. All right, so in the next part of this lesson, we're going to look at the cosine rule, which is also used for non-right angle triangles.